Hello and welcome to the Scribe platform demo. This is ScribeHub, our web portal. Here you can see the product screen, where all the products that are managed by the platform are shown. Remember that at this point, we already hold a detailed set of attestations collected from your developer's environment regarding each and every one of these products. So we are able to show specific KPIs regarding each product. And product, we can show whether or not we were able to verify the integrity of its files, whether or not all the attestations were properly signed and verified, and KPIs regarding compliance. For example, SALSA compliance, and in other cases, SSBF compliance. If we drill down, we can see individual subcomponents of each product. This is why we say that our platform is product aware, since you are able to represent a complete product tree inside the platform this way. If we click on an individual subcomponent, we see a more detailed report like we see here, with detailed SALSA compliance, SALSA level 1 or SALSA level 2, and if necessary, also other types of compliance like SSDF, like the missed SSDF shown here, and a detailed breakdown of the vulnerabilities discovered by scanning the SBOMs and the software composition analysis, and whether or not there were any integrity violations of source code files. We can also show other reports here regarding each of these components. For example, a vulnerability report. So in this report, we show all the vulnerabilities discovered, prioritized by severity, and we provide details about each vulnerability discovered, like its CVSS score, obviously. And here you can see also other sources of open source intelligence that we gather to enrich our report. So we collect the EPSS, the exploitability probability score, and we collect the KEV indications. So we know whether or not each of these vulnerabilities has a KEV, known exploitable vulnerability indication, which is a very bad thing. You shouldn't have any in your product. And we also tell you whether or not it has a fix, which means that publisher of this dependency is aware of this vulnerability and published the fix. If it has one, we will tell you what it is, and maybe the only action you need to take is to instruct your developers to move to the fixed version. We provide your details about the package manager, and since in this example we deal with a containerized application, we analyze the container image and we tell you on which layer of the container this vulnerability was discovered, whether it's the application layer or one of the infrastructure layers. Maybe different teams deal with different layers in the organization. If we drill down into the details, so yes, we know there is a fix available, and we can show you here the fixed version as described. And we also can analyze this vulnerability using the AI report. So we can produce an AI insights report regarding this particular CVE, and this will add some details about the vulnerability itself, its exploitability, and the risks involved in doing the upgrade to the fixed version. This represents the AI analysis of other organizations that made the upgrade, and whether or not they had any backwards compatibilities or problems of this sort. So this is regarding vulnerabilities. We can also manage here the VEX advisories. So let's say you have this vulnerability report, but from your internal analysis, you come to the conclusion that this vulnerability is not exploitable in your particular type of deployment or your particular use case. So you can generate a VEX advisory here, the Vulnerability Exploitability Exchange advisory, in which you can describe the situation regarding the exploitability of this particular vulnerability. So you can say here, for instance, your product is not affected, and you can select the justification for that. Let's say the code is not reachable according to your analysis. You can mark it as well not fixed, and you can provide here a detailed explanation of why this is the case. Once you save it, you can see that this critical vulnerability is no longer listed here on the top of the list. You can find it at the bottom of the report with an icon indicating there is a VEX advisory regarding this particular vulnerability, saying it's not exploitable in your use case. All these reports are exportable and shareable, so you can export the aggregated SBOM with VEX analysis, and which I just showed, and the VDR, the vulnerability disclosure report. Basically, it's a list of all the vulnerabilities discovered, and this is required by all the modern supply chain assurance framework. You can just export the file. This is one way of sharing these reports, and the other way is to use the Scribe platform itself So you can invite subscribers to your product, and these subscribers will receive an email alert every time you publish a new version, and then they can use a link within the email to log into ScribeHub and to view this report according to a permission you give them to view specific products in specific reports within the product. This is of course selective and controlled by. If we go back to our product, other types of reports you can show here is the licenses report. For example, you can see the breakdown of all the licenses discovered here, and then you can see if you have any violations of the policy, the organization regarding which licenses are permitted in products. Now, all these reports can be consumed through the web portal like I show here, or they can be exported, or they can be used as an input to the policy engine, which I will show shortly. Now let's discuss the Scribe instrumentation process in your developer's environment. Scribe supports both agentless collection of attestations and agent-based collection. Here we have an example pipeline. So we have here the build steps, which bring in all the external dependencies and builds a container image for the project. After that, we have some security scanning and analysis tools embedded as part of the pipeline. So we have here the SendGrid for static analysis, and we have here the Trivi for secret scanning, and we have SonarCube as another type of static analysis. And at the end, we have the Scribe policy gate. So in this case, we deployed the Scribe agent as part of the pipeline. This agent would collect a source code SBOM here at the beginning of the build phase, right after the checkout of the source code. This is a source code SBOM, and another SBOM at the end of the build in a process where we scan the container that was built and generate an SBOM from the Docker image. Here we also generate a provenance record to achieve SLSA compliance. After that, we have the scanners. The scan results are also ingested by the Scribe agent and uploaded to ScribeHub. Later, we can make a policy decision based on all these attestations collected on the vulnerabilities found from analyzing the SBOM, on the static analysis result, and the secret scan. We take all these into account and make a policy decision whether or not to break the build or allow it to continue. Now let's review these results inside ScribeHub. So these are the findings from the 3 scanning tools. We see here some SamGrep results, some SonarCube findings, and the Trivi results as well. All the results are shown on this single report, and they are prioritized by Scribe. So you can see here that the most severe findings and the most urgent to take care of are some exposed secrets in the source code that were discovered by the Trivi scanner. You can see that we identify directly the exact file name and the line where the exposed secret was found. So this finding is actionable. And if we drill down, we can see here a more detailed explanation, which actually tells you that what you have here is a GitHub personal access token exposed in your source code. And so this is one of the findings. And you can see here other findings by other tools, and they are prioritized by their severity. Now, based on these findings, as I showed in the pipeline, you can make a policy decision. The policy decision is taken by the Scribe policy agent. A Scribe policy is managed as code. So we have this policy catalog of 180 different security policies and security controls managed as code. And the Scribe policy engine reads these policies and makes decisions based on the attestations provided by the Scribe collectors. Here you can see all the policies managed within the Scribe U8s. And if we drill down into one of them, you can see what it means to manage policy as code. So for instance, we have this policy for allowed repository users. If we drill down into it, you can see the actual implementation as code. Each such implementation has 2 parts. One of them is the configuration part, which is basically a YAML file which contains thresholds or other parameters for this policy. In this case, you are required to define a list of users, so you can define them as part of this YAML file. The other part is the Rego code, which actually implements the logic of the policy. And all these policies as code are managed as part of the Scribe repo. They can be consumed through the UX or through a public GitHub repository, which we publish. And here it is. Most organizations just clone this repo into their own organization and manage all policies in their own environment. And this allows you to take advantage of GitOps. You can manage different versions of policies to different projects and have different pipelines run different policies and manage updates using a Git repo like is seen here. Once we have the policy results uploaded to ScribeHub, we can start measuring the adoption and the compliance of various security policies and security frameworks within your developer's environment. For example, let's consider this is the Secure SDLC Blueprint, a security framework that was published by Verify and Veracode a few years ago. This security framework includes 15 distinct security controls listed here that can be enforced and verified by Scribe. The controls include things like making sure you don't have any critical or high vulnerabilities in your build, or validate artifact signatures and signature digests. These security controls can be implemented as code using the Scribe policy engine, and we can verify and measure the adoption of this framework. So inside ScribeHub, we have the initiative adoption dashboard, which looks like that. And here you can see the same 15 security controls from the SSDLC blueprint and their adoption across the organization for each individual control. So you can see here whether or not these controls are either not implemented, may appear in gray, or they are implemented and properly verified, or implemented and are violated, and then they appear in red for each individual security control across all products and all pipelines in your organization. Another view you have here is 13 or per product. So you can see that certain products are more advanced in adoption of the entire blueprint, of the entire security framework, and some of them are more slow in adopting it, or maybe did not start at all. So you know which team is more advanced and which team maybe needs some help in implementing the security framework. Another example of our policy engine capabilities is our implementation of SSDF, the Secure Software Development Framework from NIST. What you see here is a sample compliance report for SSDF, and you see here the compliance status of the various security controls included in the SSDF for one of our products. You can see that some of them are passed and some of them are violated. For example, you have here a security control dealing with restricting admin access to a particular GitHub repo. In our policy, we set a threshold of 3 maximum allowed admin users, and from our scan, we actually discovered there are 6 admins. So this is a violation of this security control. And if we drill down into this violation report, you can see here in the evaluation tab that this result is a violation of the PS1 chapter of SSDF marks admins. So this is an example of an implementation of SSDF using policy as code. Once we have the policy results uploaded to ScribeHub, we can start measuring the adoption and the compliance of various security policies and security frameworks within your developer's environment. Another example for policy, SSBF, the Secure Software Development Framework. And here you can see a compliance report for SSDF for a particular product. And you can see here individual security controls which are required by SSBF. Some of them passed, some of them are violated. And you can see here things like the number of admins permitted for a certain Git repo in this case. So according to your policy, you allow the threshold of a maximum 3 admins allowed for this repo, and we actually scanned and discovered there 6 admins, so you see your 8 policy violation. Now let's discuss Scribe's discovery capability. In many cases, the first phase of deploying Scribe in an organization would be to run a discovery workflow to map all the assets in your developer's environment. The Scribe Discovery tool is a standalone agentless workflow that can be run to scan all the platforms in your developer's environment, such as the source code management, management platform, container registry, and the Kubernetes relevant Kubernetes clusters. In this example, we started a discovery phase. If we review it from left to right, we started with a GitHub organization, our own in this case. And according to the discovery scope that we defined, we were able to discover 2 repositories within our Git organization. And in these repositories, we were able to find several workflows that were defined in each repository and map all the workflow runs. And we can see here that a particular workflow run actually built a Docker image. This is how we scan it from left to right. Now, if we scan it right to left, we start with a particular namespace in our runtime, in our Kubernetes cluster in this case. And in this cluster, we were able to map several pods. And in specific pods, we were able to discover specific Docker images. And we can trace this Docker image to the same one that was built by the GitHub workflow. So this way, we can have a full traceability from source code to the deployment in the cloud. And this way, we can generate a lineage chart of all the assets in your developer's environment. Now, this chart allows you to make informed decisions of where you want to maybe further drill down or further deploy Scribe sensors, or where to place your policy gateways to enforce policies to ensure proper deployments to production and things of this sort. Finally, I would like to show some of Scribe's analytics capabilities. Once we have all the attestations stored in a single attestation store, we are able to use our advanced BI tool to generate various types of analysis for specific tasks. Here we have an example where we analyze the SBOM of several consecutive versions of the same product to evaluate the behavior of the number of vulnerabilities. So we can see a change in vulnerabilities from version to version and identify cases where a vulnerable component was introduced, or if we achieved a substantial improvement by changing the base image version, like we see here, and make informed decisions about these changes. Another example is a risk dashboard that we have built into our system, which allows you to evaluate the associated risk with any of your subcomponents in the several products and make informed decisions about dealing with these risks or choose to accept the risk based on our evaluation. So here you see several subcomponents and the products in which they are used and the risk associated with each and every one of these subcomponents.